Application of neural networks for analysis of sides behavior in ADR processes. Research perspectives for BRICS countries. Modeling ADR behavior with neural networks. Recent advances in artificial intelligence have demonstrated the capabilities of techniques like neural networks for modeling intricate human behaviors and psychology in fields such as marketing and finance. This raises intriguing possibilities for applying similar data-driven approaches to shed light on the complex behavioral dynamics involved in alternative dispute resolution processes. This research aims to explore the potentials and limitations of leveraging neural network modeling specifically for analyzing the interactions and psychology of sides engaged in mediation and related ADR methods. Key questions include identifying appropriate network architectures, data requirements, and evaluation techniques for developing models tailored to ADR contexts. In addition to advancing conceptual understanding at the intersection of ADR and AI, this research can help guide the responsible integration of predictive analytics in order to harness benefits while avoiding harmful applications. Overall, this work will provide valuable insights into how advanced AI capabilities could be leveraged to enrich ADR processes through an ethical, human-centered approach. Modeling ADR with neural networks. Alternative dispute resolution relies heavily on complex behavioral dynamics between disputing sides as they communicate, negotiate, and aim to reach mutually agreeable settlements. Advances in artificial intelligence raise intriguing possibilities for leveraging techniques like neural networks to model these intricate dynamics and gain data-driven insights into side psychology and interactions during ADR processes. This research aims to conceptually explore potentials and limitations for applying neural network modeling specifically to analyze behaviors of sides engaged in mediation and related methods. Through critical analysis, the study will deduce requirements in terms of appropriate data sources, network architectures, training procedures, and evaluation techniques suited for modeling in ADR contexts. Rather than developing actual models, the goal is to map out considerations for feasibility, interpretability, and responsible integration of predictive analytics to enrich understanding of alternative dispute resolution through an ethical AI lens. This foundational work will provide guidance for additional research at the intersection of ADR and artificial intelligence. Neural networks for modeling ADR behavior. Neural networks offer intriguing capabilities for identifying hidden patterns and subtle influences on the complex behavioral dynamics underlying alternative dispute resolution processes. Prior applications analyzing domains like fraud, deception, etc. demonstrate neural networks' potential for gaining counterintuitive insights about psychological and social factors that impact outcomes. These flexible machine learning models can generalize learnings across large datasets and adapt as new data accrues. However, significant limitations exist, including extensive data requirements, challenges interpreting complex model logic, and risks of oversimplifying human behaviors. Responsible integration should focus on complementing mediator skills through a human-centered approach, rather than replacing human discretion and versatility. Further research must explore pathways for harnessing the advantages of neural network behavioral modeling while mitigating the ethical pitfalls to enrich understanding of ADR interactions. Responsible neural network modeling for ADR. Realizing the benefits of neural network behavioral modeling for alternative dispute resolution while mitigating risks will require deliberate research and development strategies, including collecting diverse, naturalistic mediator interaction data at scale while protecting privacy, engineering interpretable models focused on precise objectives to avoid oversimplification, establishing rigorous training protocols to detect and reduce biases, developing intuitive model interfaces that enhance mediator judgment without over-reliance. The overarching aims should focus on complementing and augmenting mediator skills through responsible integration, rather than replacing human nuance and discretion. With careful advancement of these modeling techniques, neural networks could provide valuable insights to enhance mediator training and enrich understanding of core ADR behavioral dynamics. Responsible AI integration in ADR. The integration of artificial intelligence and predictive modeling into sensitive social processes like alternative dispute resolution raises important ethical considerations, including ensuring informed consent and transparency for all stakeholders potentially impacted by AI systems, engineering systems expressly to align with core ADR values of voluntary participation, self-determination, maintaining clear accountability mechanisms that identify responsibility for any harms stemming from algorithmic systems, implementing stringent privacy protections around data collection, storage, and use, promoting pluralistic oversight from diverse experts during model governance, enabling continuous refinement through monitoring systems and adapting to prevent unintended consequences. At this stage of research, AI should aim to augment human mediator capabilities through transparent decision support tools, not replace human nuance and discretion over settlement processes and outcomes. Further advancement of AI in ADR must focus first and foremost on integrations that improve outcomes for people through an ethical, human-centered approach. Responsible AI integration for ADR practice. Neural network modeling of mediation behaviors could provide data-driven insights to improve alternative dispute resolution practices, but integration approaches must remain responsible. AI-enhanced curricula should supplement existing training, not impersonally substitute for interpersonal learning. Interactive AI education tools could provide sides-enriching experiential learning, if balanced with human mentorship. Overall, AI systems should focus on thoughtfully augmenting ADR practitioners and participants, while human wisdom and ethical discretion remains essential. Further research must continue mapping pathways for integrating behavioral modeling that uplift human capabilities for conflict resolution. AI modeling could provide data-driven guidance to enrich nuanced alternative dispute resolution practices in thoughtful ways. By flagging potential dangers, AI could mitigate biases through cautionary signals prompting reflection. Surfacing techniques effective across cultures may broaden mediator perspectives. Modeling relationship dynamics could guide deeper exploration of side interests and values, while not replacing direct human engagement. However, integrating such AI aids into ADR practice must remain focused on selectively enhancing human capabilities, rather than impersonally automating the inherently subjective art of mediation. Discretion over whether and how to apply modeling insights should remain with ethical, qualified mediators devoted to principles of conflict resolution. This conceptual analysis revealed intriguing possibilities but also risks and open questions surrounding the application of AI techniques like neural network modeling to provide insights about mediator and side behaviors in alternative dispute resolution contexts. Key issues requiring further research include empirically validating feasibility assumptions made in the theoretical inquiry, soliciting broad input to inform responsible human-centered design, and extensive testing to prevent potential harms. Technical safeguards must be developed to mitigate risks stemming from biases encoded in training data and lack of model transparency. Differences between paradigms of conflict resolution also warrant examination to avoid imposing biased assumptions. Overall, collaborative interdisciplinary research will be critical for advancing AI in ways that enhance mediator capabilities while aligning with mediation's core values and ethics. Prudent exploration of this emerging intersection of technology and conflict resolution can yield AI systems that provide nuanced data-driven insights to augment alternative dispute resolution theory and practice. This conceptual analysis suggests neural network modeling techniques have promising capabilities for developing data-driven insights into mediator and side behaviors. However, realizing benefits will require extensive research to address challenges surrounding data sufficiency, algorithmic biases, interpretability, and effects on mediation practices and ethics. If thoughtfully designed and deployed, AI could provide tools to enhance mediator training and strategy. But premature application without safeguards risks undermining human expertise and dignity essential to conflict resolution. As a conceptual inquiry, limitations include lack of primary data and empirical validation. However, the study contributes an analytical framework and highlights critical issues warranting exploration at the intersection of AI and alternative dispute resolution. Further research directions involve investigating diverse viewpoints to guide design, proposing legal frameworks to govern use, and monitoring deployments to enable continual improvement. Through deliberative inquiry, future work could responsibly advance AI and ADR by selectively leveraging modeling capabilities while prioritizing human wisdom, ethics, and well-being. Thank you for the attention.